33. In the diagram below, a stationary source located at point S produces sound having a constant frequency of 512 Hz. Observer A, 50 meters to the left of S, hears a frequency of 512 Hz. Observer B, 100 meters to the right of S, hears a frequency lower than 512 Hz. So this guy receives the actual frequency of 512, and this guy gets something lower than 512. And the source is stationary. Which statement best describes the motion of the observers? So even without reading the choices, we know the source is stationary, right? So, and by the way, this is a problem about the Doppler effect. Doppler effect. It has to do with when a source is producing a sound at a certain frequency. The observer, observer A, observer B, will receive the same frequency if they're not moving relative to the source. So observer A is receiving 512 Hz, which is exactly what the source is producing. So A must be stationary also. So A is also stationary. And there's two other situations. Observer B could either be moving toward the source or away from the source. So if they receive a lower frequency, then does that mean they're moving toward the source or away from the source? Well, if you think about the source as emitting these wave fronts at a so these are supposed to be equal to each other. So the source is periodically emitting these sounds, right? And these wave fronts are equidistant. If an observer, so let's take observer B, is moving toward the source, he's going to go from one wave front to the next as they're being emitted, and he's going to pass the crests faster than he normally would if he just stayed still. So that would result in observer B receiving a higher frequency. If, on the other hand, observer B is moving away from the source, the same directions that the crests are moving in, he's not going to receive them as often, which is going to result in a lower frequency. So that's actually what's happening in this case. Observer B is moving away from the source, and that's why he's getting a lower than 512 frequency. So the best choice is 4. Observer A is stationary. He gets the same frequency because he's not moving relative to the source. And observer B gets a lower frequency because he's moving away from the source. So it's taking longer for each of those crests to reach him because he's moving away from them. If he was moving toward them, it would take less time. That would be a higher frequency. And the way that I always remember this is I think about being out in the street and a car comes by and it's playing music really loud or whatever, and it sounds kind of funny, right? It almost sounds like as the car is coming toward you, it's too high of a pitch. Maybe you know the song, it doesn't sound quite right. It's high pitched. That's when it's moving toward you, right? And then the moment, if just for a brief moment you could imagine that it's just passing you, so it's pretty much relatively still relative to where you are, it sounds normal. It sounds the way it's supposed to sound. But then as soon as that moment comes and goes and it's going past you again, now all of a sudden it sounds like the pitch is too low and it's moving away from you. So that's exactly what's going on here. Pitch is too low, it's moving away from the source. Pitch is too high, it's moving toward the source. So when I say pitch, I mean the same thing as frequency. These are the frequencies. And this is how you're moving relative to the source.